Hi, welcome to question 3. So in this question, we know that we have a bug in the DQ method, and it's our job to figure out what the bug is and where exactly it is occurring. So inside the DQ method, we're doing 3 things. So we first get the element at index 1 in our array. And remember, this is going to be the item in our priority queue with the smallest priority because we always fill in our array representation from index 1, all right? So this is corresponding to the root node of our binary min heap. Then we swap the root with the bottommost rightmost leaf node value, okay? And then once we have done that, we bubble down starting from the very root, which is now the actual value of this bottommost rightmost leaf node, okay? And I'll show you an example of what these 2 steps are actually doing. But to me, it seems like this is fine. So let's go down to the bubble down method. Maybe the bug is there. Takes in an int index, okay? And then it takes in the size, all right? So we save that as n, and then while index times 2 is less than n. So this is basically checking whether the children of index are within range, right? If the left child is less than n, then it has to be within range for the left child. But we're not necessarily checking the right child, so that might be a problem. Binary min heap.get index greater than binary min heap.get index times 2. So this is checking whether the binary min heap property is not satisfied. In other words, the parent value is greater than, not smaller than, the left child value. And then if it is, then we swap the parent with the left child, and then we update index to go down to the next level. One thing that jumps out at me is that we're only checking the left child, right? It could be the case that both the left and the right children are smaller than, are smaller than the parent, right? In which case we have to make sure that we swap the parent with the smaller of the 2 children. So it's not always the case that the left child is going to be the one we swap with the parent. It might also be that the right child is the one that we swap. So here's an example for part A of a 5-node binary min heap that shows the bug in the DQ method. So let's actually run through the DQ method on this binary heap. So what happens first is that we swap the 1 and the 5, okay? So now to redraw the resulting binary min heap, 5 is going to be the new root. Then I'm going to have everything exactly the same, okay? Except now, remember that I wanted to remove the root, and the root value was 1. So this new node 1 is going to, oh, whoops, I deleted the entire thing. Let me just redraw really quick. So I have 5, I have 3, I have 2, I have 4, and I had 1. So what I want to do is I want to now delete this 1 because that was the value that I wanted to delete from my tree. Okay, so now what I need to do is call the bubble down method, right, to make sure that my heap property is satisfied. Right now it isn't because 5 is actually bigger than both of its children. But remember that in the code here, it only checked whether the parent is greater than the left child. So following this exact code, we only check whether 5 is greater than 3. It is. So in this case, and also index times 2, which is going to be, if we actually want to draw out the array representation, 1, 2, 3, 4, 1, 2, 3, 4, yeah. So this is going to be index 0. We don't have anything at index 0. This is going to be at index 1, 2, 3, and 4. So a little lopsided array, but hopefully it makes sense. Okay, so in our case, index times 2 index is equal to 1, right? So index times 2 is 2, and 2 is definitely less than n, so we're good. So now we get into this check of whether the parent is greater than the left child. It is, and so we swap them. So now 5 is going to go down, and 3 is going to go up. Okay, and then we continue bubbling down. So now we need to check whether 5 is greater than 4, in which case it is. And so then we need to swap them again. So this is our final binary min heap. And the reason it's final is because 5 has now become the leaf node, and it's also its children are also out of range of our array, so either way we'll have to stop the iteration. But notice that it's not the correct min heap, right? We actually have a smaller element than the current root that should be our root, which is 2, right? 2 should be the new root. Because remember, once we remove the min, the next min element becomes the new root. In this case, it should be 2, not 3. And so there was something that went wrong. And that bug is precisely because we only check whether the parent is greater than its left child instead of checking whether it's bigger than both of its children, and then if it is, switching with the smaller of the 2 children.